This is part one of a review lesson over the basic rules of differentiation that we've done in class. Keep in mind, I'm just going over the basic rules and doing a few examples. I'm not deriving any of the rules. We have derived most of these rules in class using the limit process. So if you have any questions about that, you can see me. The constant rule just basically says if you have a constant when you take the derivative, and remember that the derivative is considered a rate of change, it's going to be zero. And if you think of the derivative as a rate of change, it's pretty easy to see that any constant would have a graph of a horizontal line. It's never going up, never going down, so with the derivative sort of being a judge of how fast it's going up or down as you go from left to right, if it doesn't do it, it has to be zero. And that's something that you just need to know, and hopefully if you understand the derivative as a rate of change, that won't be too much of a problem. When the numbers 2 or 10 or -4, students don't normally have trouble with it. It's when they do things like this to you on the AP exam that students have trouble. But all four of these are constants. Now this one on the end doesn't happen too much because it's not simplified. You can actually change that to square root of 2 over 2. But the square root of 10, a common mistake is students will go 10 to the 1/2 and try to use the power rule on it. That is a constant, so the derivative of the square root of 10 is 0. E to the second, E is a constant, and raising it to the second power, it is still a constant, so you would not use the power rule on this. It would just be 0. And pi, of course, is a constant. So watch out for those weird ones, but any constant would have a derivative of 0. That brings us to the most used rule. And sometimes it's the rule that is used even when you can't use it. So be very careful with this rule, but it is a very useful one. If you have a variable raised to a real number power, then you may use the power rule. And the way you use it is you take this number and you make it the leading coefficient of this term, and then you decrease the degree of this by 1. Now you need to watch out, because when you do this, occasionally it will not be differentiable at 0. That's where I say watch. At x equals 0, x to the n minus 1 needs to be defined. That's of course assuming that 0 is defined in the regular function. For example, x to the 1/3, when you take the derivative of that, that's going to be you bring the 1/3 to the front, and then 1/3 minus 1 is -2/3. 0 is defined here, but it is not defined here because that negative basically throws the 0 in the denominator. So this would not be differentiable at 0. So to be technically correct, I would need to say where x is not equal to 0. Or just keep that in mind, that if they ask where is it differentiable, that you don't see very often because you know it's undefined there. But sometimes if they say where is it should be differentiable, people will forget that 0, it's not differentiable. What you would have here is a vertical tangent, and that's what occurs there in the graph. If we look over on the side, we have some examples here. Students normally do not have too much trouble with this, but you move the 5 to the front, the degree goes down to a 4, so the derivative of x to the 5th is 5x to the 4th. Here you need to remember that the notation changes. If this is f of x, put a little prime there. Watch your notation. Okay? Here I would change the x to the 1/5. Then you may use the power rule. I'm going to say g prime of x. That means the derivative of g of x. The 1/5 moves to the front, and then 1/5 minus 1 is -4/5. This is one of those again that you have an issue with 0 not working there. Okay, so please watch out for that. Here you don't have to worry about because 0 didn't work in the first place. But I would definitely change this to x to the negative third, and then you can either say dy over dx. I like that terminology, but you can also say y prime. And you move the negative 3 to the front, decrease this by 1. So these, keep in mind, you could change this back, put this on the bottom, and it'd be the 5th root of x to the 4th. You can move this to bottom, be negative 3 over x to the 4th. Okay, but a very important rule, the power rule. In fact, like as I said before, the biggest problem with the power rule is people will use it when you cannot use it. For example, up here at e to the second, changing that to 10 to the 1/2, that's common occurrences, people using the power rule when you cannot use it. The constant multiple rule just basically means is if this is something you can take the derivative of and you have a constant on the outside, you can simply take the derivative of it and leave that constant. For example, over here you have a 4 at the top. The way this is normally done, I'll use the y prime this time, is you think of the 4 on the outside and then you have x to the negative 1. You would actually made a mistake on the notation. That's still just y. So y prime, I'd leave the 4 out here, bring the negative 1, decrease this by 1, the degree. 4 times negative 1 is negative 4. And then you have x to the negative second, or you can say negative 4 over x to the second. This one, same thing. I would rewrite it as 2, and then you have x to the 1/2. When you take y prime, leave the 2 out there. The 1/2 runs to the front. 1/2 minus 1, negative 1/2, so you have that issue with the 0 again. 2 times 1/2 is 1. So you actually have x to the negative 1/2. This one, a lot of times students make a mistake on this one. When you do it, if you follow your rule, it's not that bad. But this is x to the first power, so the 1 moves to the front. You decrease the degree to 0. Anything to the 0 power is 1, so this becomes 1 times negative 4/5. So you have negative 4/5. I'm going to finish the first part of the basic rules. I did not write the sum and difference as a rule. I just want you to realize that when you are adding and subtracting terms, as long as you can take the derivative of each term, you can simply take the derivative of each one and it will be the derivative of the sum and or difference. So on this one, the first one is a pretty classic power rule. X to the third, I bring the 3 to the front, decrease this degree by 1 to get 2. This one, you have minus 4. Remember, this is x to the first. You're going to find that you're not going to be doing this as much. You're just going to remember it, but I want to show that. And then, of course, the derivative of the constant 0. So you get 3x squared minus 4. Remember, if you think of rate of change, negative 4x, it's like the slope is just negative 4. And for the final one, I can bring negative 1/3 out. And the derivative of x to the 5th is 5x to the 4th. Plus, bring the 4 out. The derivative of x to the 4th is 4x to the 3rd. One problem students have is they try to do all this at once, and with practice you can do it, but in the beginning it really helps to go ahead and move that out. Then of course you have that 1x to the 0. That's a constant. Pi squared is a constant, so that would just be 0. Then it's just a case of multiplying your coefficients. And that becomes minus 2. So that's the derivative. Okay?